Welcome everyone. An iron core coil. An iron core coil. Iron core coil is connected in series with an electric bulb with an AC source. So a question of it is obviously a question of AC, and this iron core coil is nothing but is acting like an inductance here. Okay, inductor here which have some inductance. So let us at first discuss what we have learned, that is this is a air core coil. Okay, air core coil, that means simply a winding is there, and if you know the inductance of this coil is L equal to mu naught N square A divided by L, where mu naught is the free space magnetic permeability. Since the space between these windings is not filled out by anything, it may be air, so we can say it is mu naught. So for the air core coil we are using the free space magnetic permeability capital N. The capital N is nothing but the number of turns, total number of turns of this coil, and small l is the length of the coil, and capital A is the cross sectional area of the coil. Okay, and this is a iron core coil. That means within the winding a iron is inserted. If the iron is inserted, then obviously the space is filled up with the iron. Now we cannot use the magnetic permeability in free space, but the magnetic permeability of the iron, that is mu, here we have used. Okay, and obviously capital N is the total number of turns, capital A is the cross section area, small a is the length. Okay, so you know that mu, which is mu is nothing but can be written as the product of the relative permeability, relative magnetic permeability multiplied by the free space magnetic permeability. So I am placing it here. So obviously this mu naught N square A divided by L. So this expression, this mu naught N square A divided by L, so this expression is similar to that of the inductance of this iron core coil. So simply if you insert an iron in the winding, then what will happen? The inductance of the coil will increase. By which amount? By the mu r amount, where mu r is the relative magnetic permeability. Okay, so obviously this L prime greater than L, this relation should be satisfied. So if you insert an iron core within a coil, then its inductance will increase. So keeping this thing in mind, read the rest of the questions. An iron core coil is connected in series with an electric bulb with an AC source as shown in the figure. When an iron piece is taken out of the coil, that means when the iron piece is taken out of the coil, then according to this discussion, this iron core coil transformed into a air core coil. That means the inductance of the coil is decreased here. Okay, so here after that it is said the brightness of the bulb will decrease, increase, remain unaffected and fluctuate. So obviously the brightness means the intensity of the bulb. Intensity of the bulb is nothing but depending on the power consumed by the bulb. The power consumed by the bulb is written by the formula, that is the I square R. That is the intensity of the bulb is depend on the power dissipated by it or the power consumed by it. That is the I square R, which is also equal to that of the V square divided by R. Okay, so we have to check it out that when the iron piece has taken out, when the inductance of the coil is changed, then how the current will change, because it is the here this iron core and this bulb both are connected in series. Here I can consider this bulb's filament as a resistance capital R. So here R and L. Okay, R and L prime we can say. It is the iron core. Okay, so if this L prime and R are connected in series, so our formula of impedance will be R plus J multiplied by omega into L prime. I am writing down J prime here. But when the iron core is taken out from this coil, then the impedance of the coil will be capital R plus of J multiplied by omega into L. Okay. When the iron core is inserted within the coil, at that time the current should be written as the peak value of the voltage source divided by the impedance. So I am just writing down that is V naught root over of R square plus of omega square L prime square. It is the magnitude of the impedance and the current is then I prime. Okay. I am writing down here the magnitude obviously can be written as R square plus of omega square L prime square, magnitude of the impedance. I am using the magnitude here since I am using the peak value of the voltage, so I am getting the peak value of the current here. Okay. Similarly, when the iron piece is taken out at that time, this is the impedance. So in that particular case, the magnitude of the impedance is nothing but R square plus omega square L square. In that particular case, what is the current? What is the peak value of the current flowing through this circuit? That is V naught divided by Z. It is V naught divided by root over of R square plus of omega square L square. Now just we can do a simple comparison. I prime, which one is greater? Let me check. Which one is greater? L prime is greater, L is less. So here L prime is greater, L is less. So in that expression, since L prime is greater, so denominator of these expressions will be greater compared to the denominator of this expression. Okay, denominator of I prime is greater compared to the denominator of I. Okay, so obviously the I prime is less, I is greater. Okay, so before I prime is less, capital I is greater. So the current flowing through the coil after taking out the iron piece from the coil will increase. Okay, if you have any problem in understanding this mathematics, then we can do it easily. Let us take the ratio of I prime by I. I prime is V naught divided by root over of R square plus of omega square L prime square divided by putting the value of the I, V naught divided by root over of R square plus of omega square L square. So this thing will become V naught, obviously these two will cancels out and this two will become root over of R square plus of omega square L square divided by root over of R square omega square L prime square. Okay, what you know? You know that L prime is greater than L. Okay, so obviously this quantity is greater than this quantity, so we can say it is less than 1. Okay, so obviously from here we will get I prime is less than I. Okay, so the option B is our correct answer. If you have taken the iron piece from this coil, taken out this iron piece from this coil, then the current will increase. If the current will increase, then the power consumed by the bulb will increase. Then obviously what will happen? the brightness or the intensity of the bulb will increase. Okay, so option B is our correct answer. Thank you all of you.